Problem statement was player A or player B will win the match provided he wins 2 games, and there was a possibility of draw as well as losing 1 game is acceptable. Okay, so let us define the events properly and try to do the calculations, and we might take help of our previous knowledge while doing the calculations. So this is game level 2, which is going to be either he wins without losing a game, that means losing 0 games, or he wins by losing 1 game. Okay, now what is L0? A wins by losing 0 games. And L1 is A wins by losing 1 game. ठीक है, let GI be the event such that A wins at the end of ith game. And loses 0 games. And let us call Fi is the event when A wins at the end of ith game and loses exactly 1 game. ठीक है, so our final answer would be A wins at the end of ith game and not loses any game. So we may get our result of the match after second game. After we may get result, or we may get result after 3 matches, or we may get result after 4 matches, or dot dot dot. So this is, if he is not losing any game, then this is the total number of possibilities that we have. If he is losing 1 game, then we may end up getting result after third game, or after fourth game, or after fifth game, or dot dot dot. Okay, so if GI A wins at the end of ith game, GI, if we consider GI, then as we said last lecture that ith number 1, 2, 3 dot 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 dot, ith game is definitely win, and there will be 1 win somewhere in between, and all remaining will be D's. So every time the last one is going to be win, therefore let us say there will be total W will be equal to 1 and D's will be equal to I minus 1 minus 1. So I minus 2. Total D's are going to be I minus 2. So in how many ways we can get this? In how many ways we can permute, we can arrange 1w and I minus 2 d's. So total I minus 1 letters we have to arrange. So I minus 1 factorial ways divided by I minus 2 repetition factorial. These many ways we can arrange this, and there will be one p square, I mean win and this win, so that is going to be p square, the probability. And how many r squares will be there? Draws I minus 2. Understand this. This is the quantity. Will this quantity give us the probability after ith game? Okay, and therefore this quantity, whatever we have got, if we want to find out the probability of our L0, then we have to put I is equal to 2, put I is equal to 3, put I is equal to 4 and add them. So the probability L0 is going to be sigma I goes from 2, upper bound not there. Keep doing. Do you understand this? This is exactly equal to sigma I goes from 2 to n tends to infinity, I minus 1, p square is constant, r raised to I minus 2. Okay, and if we do push pull here, if we start our r from what? You want to start it from 0. So you are pulling the index p square sigma I starts from 0. You pull the index, you push the index here. So I goes I plus 2. So it becomes I plus 1 and r raised to I. Correct? I goes from. So if we really expand this, how is it going to look like? It is going to look like p square inside bracket I is equal to 0, that is 1 2r plus 3r square plus 4r cube plus dot dot dot, and we are familiar to this animal. Okay, so let us finish this part here itself and then go for f's, calculation of f's. This is our 1 upon 1 minus r bracket square. This is our elbow notation. If you remember, when we were doing it for real numbers, 1 upon 1 minus x raised to 2. The sequence for that, the generating function for this sequence 1, 2, 3, 4, 5, 6, the generating function for that was 1 minus x bracket square. You may revisit and find it out, because this coefficient is becoming smaller. I mean, it is 1 more than the index, and that is precisely when we got 1 minus x bracket square. I hope you are with me, and therefore you end up getting this equation as p square into 1 minus r raised to minus 2, which is equal to p square upon p plus q bracket square. This calculation for probability of a winning without losing a game is p square upon p plus q bracket square, which otherwise also we had found out, but this is actual counting considering all possible cases. Now let us do this calculation for fi by losing one game. Okay, so fi 1 2 3 4, and at the end of ith game A wins. So of course the last one is W. He has got W somewhere also, and he has got L also somewhere. All remaining are D's. Okay. So we have we have one W. I mean, what permutations we are supposed to consider? Permutations of all these numbers. So we have one W, we have one L, and how many D's we have? I minus 3. I minus 3 D's are there. Okay. So permutation with repetition, there are total I minus 1 numbers, they will get permuted, divided by 1 minus 3 I minus 3 factorial D. L and W are distinct. Therefore, these many ways they will get permuted. Then there will be P square for 2 wins and Q for 1 loss. All these we have to losing 1 game. All this we have to add for I going from 3 to infinity. So for all practical purposes, what does this mean? This means sigma I goes from 3 to up, I minus 1 into I minus 2, it R R raised to I minus 3. I minus 1, I minus 2 into P square Q R raised to I minus 3. If you do push pull, P square Q comes out, sigma I goes from 0 to infinity. You are pulling by 3, hence you should push by 3. I plus 1, I plus 2, R raised to I. Now if you really write this sequence, then it is P square Q inside bracket, I is equal to 0, it is 1 into 2 plus 2 into 3 R plus 3 into 4 R square. And then you will realize that this is also our familiar friend. I mean, you differentiate the earlier and get the next generating function. This is going to be P square Q. Again, elbow notation comes in this picture also. I mean, here also it is elbow notation. This is elbow summation of I plus 1, I plus 2. Here also there is elbow, which we can cross check. But essentially we know by differentiating 1 upon 1 minus x square, we are going to end up getting something 1 upon 1 minus x cube function. This is going to be 1 minus r cube, 1 minus r raised to minus. And therefore our probability is p square q upon p plus q raised to 3. इसके लिए कमी बरोबर आहे सगळं एखादा कोएफिशियंट राहिला एक 2 राहिला कुठेतरी मला
सर डिफरेंशिएट करताना -2 वर नाही
एक कोएफिशियंट तिथे येणार आहे कोणता तर आता आपलं जनरेटिंग फंक्शन 1 upon 1 minus x square is equal to 1 plus 2x plus 3x square plus 4x cube असं होतं. तर याला आता सगळ्याला जर डिफरन्शिएट केला तर काय येणार आहे -2 into 1 minus x raised to -3 into -1 is equal to 2 plus 6x square बरोबर plus 12x, no, 6x plus 12x square plus 20x cube and so on. बरोबर आहे. तर आपला आता this is equal to this is equal to 2 upon 1 minus x cube. Whatever we want, this is exactly what we want, exactly equal to 2 upon 1 minus x raised to 3. So when I am replacing this here, I must write to here. Arey, समझते का? It is not because I knew the answer, it is because of this. If we differentiate 1 minus x square, LHS, RHS, we are going to get the desired sequence here, and that 2 will generate over there. Okay, and hence after this the calculations are exactly same. PL0 plus PL1. Probability is, the final probability is PL0 plus PL1, which is P square upon P plus Q bracket square plus 2 times P square Q upon P plus Q bracket Q, which is P cube plus 3P square Q upon P plus Q bracket Q. Total is this much, right? So our, when this was what? P2. What was our PE1? PE1, do you remember what was our PE1? It was P square upon P plus Q bracket. What was PE1?
So P upon P plus Q.
Sorry, not square. P upon P plus Q. This was our PE1. This is PE2. Can we guess PE3? Suppose A wins after winning 3 games. Calculations are going to be involved. But is there a pattern? PE3 is equal to, without losing a game, by losing 1 game, by losing 2 games. A wins by this, and the answer is going to be, this is first power, this is third power, P raised to 5 plus 5P fourth cube plus 10P cube Q square upon P plus Q bracket raised to 5. And if you really work hard and do this, you are going to get this answer. This is correct. That is what is the chess problem we would like to do in actual calculation. So why I am doing this method is, sometimes if you do not have that intuition of doing it some other way or recursion, so as if a new match is started, that kind of intuition, if there is, or you don't get that idea, then you should be able to count what is happening, and this is pure counting. Total space omega, there are H1, event H1, event H2, event H3, there are many events like that. HK, K events. And there is an event A which is taking place. Okay. So calculations are as follows. Probability of A is equal to probability of A intersection omega. Correct? Because probability of A I am trying to find out in the entire space omega, it is going to be probability of A intersection omega. It is as simple as that. Then what is probability of A intersection omega? probability of A intersection. What is omega, by the way? Omega is H1 union H2 union dot 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 union HK. All those events are there, mutually exclusive, collectively exhaustive. Now, we have those De Morgan's law to help us out in this case. I mean, this is set theory inside P. Inside P, it is set theory. A intersection H1, that is first union A intersection H2, it distributes. Union dot dot dot. Union A intersection HK. This probability we want. And then when it is union, this or this or this, therefore probability of A intersection H1 plus probability of A intersection H2 plus probability of A intersection HK. Up to this point it is very clear. Now we can divide all by probability of 9. Not all. I can write this as P A intersection H1 upon probability of H1 into probability of H1 plus P A intersection H2 upon probability of H2 into probability of H2 plus dot 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 plus P A intersection HK upon probability of HK into probability of HK. Correct? And this is, if you go through our definition of conditional probability, then the first part of this expression is probability of A given H1 into probability of H1 plus probability of A given H2 into probability of H2 plus probability of A given HK into probability of HK. That is what is our total probability theorem. We did it with some other notation other time, but if there are k mutually exclusive and collectively exhaustive events, then this is what is going to happen. Okay. Therefore, let us do Bayes' posterior probability theorem. Delete. Now, in English, how can we understand PAH1? PAH1, given H1. What is this? This is conditional probability. Probability of event A happening given that H1 has already happened. Probability of A happening given that H1 has happened. Okay, very good. But suppose I write P H1 given A. How will we convert this probability into English. Probability of H1 happening given that A has already happened. Exactly same, replacing A by H1, probability of H1 happening given that A has happened. Now, okay, English wise this is correct. Let me give you one example. Probability, you have been given an exam. There is an exam. Probability of student knowing the answer, say suppose 0.6. Probability of student guessing the answer, it say 0.3. And probability of student copying the answer, it says 0.1. Then okay, now the question that I am going to ask is, student has got the answer correct. What is the probability that he guessed the answer? Okay, this is posterior probability. Student has got the answer correct, so he can get the answer correct by his knowledge, or by guessing, or by copying. He got it right. Now the question is, what is the probability that having got the answer correct, what is the probability that he has guessed it? This is something like this. Because in the diagram, if you see H1, H2, H3, H4 are collectively exclusive, and mutually exclusive and collectively exhaustive events. So they are happening first. As far as omega is concerned, they are occupying the entire omega space. And then there is one subset which is coming, which is A. So first H followed by A. But then now you know the A. And you know A, and you are asking, what is the probability that this A that I am having right now belongs to H1? What is the probability that it belongs to H1? Or what is the probability that it belongs to H2? Or what is the probability that it belongs to H3, or so on? That is what is the meaning of this. What is the probability that A event has already occurred, and that occurred A element, whatever has happened, belongs to H1. That is posterior. Do you understand what I am trying to say? We will solve problems and you will get to know. But then your total probability theorem talks about A upon H1, A upon H2, A upon Hk. And what is asked is P of H1 upon A, or P of Hi upon A. Having got this particular result of A, what is the probability? What is the probability? You have picked up a black ball from 3 boxes and their configurations were different. You finally have got a black ball in your hand. Then what is the probability of this black ball, which I have got in my hand right now, belongs to box number 1 or belongs to box number 3? That is posterior probability. So algebraically we need to find out the formula to find out this, and then go and try to solve problems so that we understand it in a better way. So we'll write meaning of this. This is P of, let us do it for 1 and then generalize it for I or K or whatever. So P H1 given A, if I want to write, then it, by definition it is H1 intersection A upon probability of A. Is that correct? Which is equal to, I have this with me. This is easy. Probability of A given h1. This is easy. This number is available with us. So now I can write that number p a given h1 is pa intersection h1 upon ph1. So multiplied by, do you understand what I have done here? We know PA given H1 is equal to PA intersection H1 divided by PH1. Correct? So PA intersection H1 and H1 intersection A, they are same. So I am replacing this quantity by this fellow. And I am dividing it by PA, but PA is PAH1 into PH1 plus PAH2 into PH2 plus dot 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 P plus PAHK into PHK. That is total probability in the denominator. Total probability of denominator and probability of A given H1 multiplied by probability of H1 in the numerator is going to give you PH1 upon A, exactly opposite, exactly reciprocal that you are asking for, which is part of total probability. So there are k terms in total probability theorem. Any one of them goes in the numerator. It is PHI upon A, which is P A given HI into PHI divided by sigma P A given HI into PHI. Correct? Yes. I was from A. This is a specific I and these are total I's. That is what is your Bayes, spelling Bayes, Bayes posterior probability theorem. That is what is the theory part of your probability. Suppose there are three similar boxes. Box I contains I white balls and one black ball. One ball is chosen at random from any of the three boxes and the ball is white. What is the probability that the ball belongs to box number 3? First easy problem on posterior probability. Get me the numerical answer. Okay. So first thing that you are choosing is the box at random. Okay. That means you are choosing either box number 1 or box number 2 or box number 3. Correct? So now I don't draw this. What is the probability that you choose box number 1? It's a random choice. Somewhere word random is there. A ball is chosen from at random from any of the three boxes. So here probability is 1 by 3. Here probability is 1 by 3. Here probability is 1 by 3. Okay, so you are choosing either 1 or 2 or 3. This is 1, this is 2, and this is 3. Okay. Now then what is the probability of you getting white ball? Now how do you draw diagram? Suppose this is, let me have a white ball here and let me have a black ball here. And we will do complete analysis and then answer whatever we want. So from one, if you get white ball, or from one you get black ball. What is this? This is 1/2 because there are only two balls, one black, one white, one black, one white. So this is half and this is also half. Then What is the probability from box number 2 you getting white ball 2 by 3 and you getting black ball 1 by 3, correct? And what is the probability that you get white ball from box number 3 3 by 4 and black ball 1 by, is that correct? Therefore, what we are supposed to do now is, what is total probability? What is total probability of white ball? So you look at what all arrows it has received here. It has received arrow from first like this. So total probability for white ball is 1/3 into 1/2. That is if it comes from first bracket, first box. Plus if it comes from second box, probability of the ball being white is 1/3 into 2 by 3. And if it comes from third box, then probability is 1/3 into 3 by 4. That is total probability of getting white ball. Okay. And then it is asked that the probability that the box belongs to 3, that means the third component is in the numerator. That is what we have done the formula for. So this is the required probability. The answer is 9 upon 20. Questions, if you have not understood. Next, suppose there are two electrical components. Let me write fast. Chance of first component fails is 10%. If first component fails, the chance, if first fails, the chance second fails is 20%. But if first works, chance of second failing is 5%. Calculate following probabilities. Find 1. At least one of the component works. What is the probability that at least one of the component works? Then second, what is the probability? अरे बाप रे, हा स्ट्रेट फॉरवर्ड क्वेश्चन है, हा पोस्टीरियर नहीं है. Exactly one of the component works. Third, second component works. This is not posterior probability, straightforward. Anyway, I have given you, so you should solve. Tree diagram. First component works, 90% possibility. Fails 10%. If first component works, second also works, 95%. Second fails, 5%. If first fails, second works, 80%. Second fails, 20%. At least one component works. So first event is at least one of the components work. That means it should be 1 minus both fail. Both fail is 0.1 into 0.2, which is equal to 1 minus 0.02 is equal to 0.98. That is answer for 1. Answer for 2. Exactly one component works. So if first works, then second fails, 0.9 into 0.05. This works, this fails. This fails, this works. Plus 0.1 into 0.8. Correct? Is equal to 0.125. And third, second component works. 95 into 90 plus 0.8 into 0.1 is equal to 0.930. What could be the posterior probability question here? It is known that second component works. It is known that second component worked. What is the probability that first also worked? So, because there are only two branches, we can direct. So, total probability of second component being worked is 0.9 into 0.95 plus 0.1 into 0.8. That is the total probability of second component is worked, and posterior is what is the probability the first work. So for first we have 0.9 into 0.95. One of the parts of the denominator will appear in the numerator. That will give you answer for this, whatever is that answer. That is posterior question on this setup. Now let us solve that guessing and knowing. How will you solve this? Probability that student has guessed the answer. Okay, let me write down the problem. In a given question, where 4 options are available, and single correct. In a given question where 4 options are available and single correct type, probability that A knows the answer is 60%. A probability of A guess the answer, guesses, is 0.3, and A copies the answer is 0.1. A got the answer right. What is the probability that question 1 he knew it, 2 guessed it, 3 copied. All three answers we can find out. So try to get the answers. Is like this: either knew it, or guessed it, or copied it. This is 0.6, 0.3, 0.1. Then wrong. This is 1, 0. Right, wrong. 0.25, 0.75. Right, wrong. 0.5, 0.5. No, answer is right. So let us write down the denominator. For answer being right, that is total probability of A, 1 into 0.6 plus 0.25 into 0.3 plus 0.5 into 1. Okay. So probability of answer, probability that he must have guessed it, given that answer is right, is equal to 1 into 0.6 in the numerator. This is denominator. Probability that he guessed answer, given that answer is right, is 0.25 into 0.3 in the numerator and the same denominator. And probability of we copied the answer, given that answer is right, is 0.5 with a 0.1 by into 0.1 divided by total probability. These are the three answers. Simple, straightforward. The moment you draw your T diagram, things become simple. A signal which can be green or red with probability 4 by 5 and 1 by 5 respectively is received by station A. And then is transmitted to station B. The probability of each station receiving the signal correctly is 1 by 3. Sorry, is 3 by 4. If signal received by the station B is green, then probability that the original signal was green is okay. Now the first signal which is given, so signal is given from this some machine, and first statement is it is going to be green 4 by 5 times, and 1 by 5 it is going to be red. So this is green signal, this is red signal, this is original. Okay, now received, okay, is received by station A. Original signal, if it is green, then now this signal is being received by station A, and station A will receive some signal and will transmit some signal to station B. Okay, so probability each station receiving the signal is 3 by 4. So if green is there, then station A will receive green by 3 by 4 possibility and will receive red, station A will receive red by 1 by 4 possibility if the original signal is green. Similarly, if the original signal is red, it will be green by 1 by 4 possibility and it will be red by 3 by 4 possibility. This is received by station A. Now station A transmits it with the same condition. So station B receives green by 3 by 4, red by 1 by 4. If this signal is red, green by 1 by 4, red by 3 by 4. If original signal is green, received by B is green by 3 by 4, 1 by 4, red. Green 1 by 4, red. So this is 3-level problem. Okay. Therefore, finally, what is a signal by B? If signal received by B is green, then probability that original signal was green. So in the denominator, we should have total probability of receiving green signal. So we need to this plus this plus this plus this. So in the denominator, you will have, for first you have 3/4 into 3/4 into 4 by 5. That is first branch, plus for this you have 4th into 1/4 into 4 by 5. This is per second. For third, it is 3/4 into 1/4 into 1 by 5. Plus for fourth one, you have 1/4 into 3/4 into 1 by 5. This is total probability of B receiving green signal. Now, what is the probability that original signal was green? The original signal was green. That means we have to follow this branch. So these two additions will be there in the numerator. 3 by 4 into 3 by 4 into 4 by 5 plus 1 by 4 into 1 by 4 into 4 by 5. That is the required probability. If you calculate, you get 20 upon 23. Okay. That is how it should be solved.
Let's say population half.
Okay, next problem is half percent population is affected by the disease. Probability that person tests positive given he is positive is 0.995. Probability that person tests positive given he is not diseased, that means he is not affected by the disease, is 0.01. Find the probability of he being diseased given that he is tested positive. It is given in the first statement that probability of being deceased is equal to 0.0051, 0.00, and probability of being healthy is 0.995. Correct? E be the event when person gets the test. Test positive. Okay, that is our event when a person gets the test positive. So person tests positive given that he is diseased. Person tests positive given that he is diseased is 0.995. Person tests positive given that he is healthy 0.01. So these are all things that are given to us. Now we are asked to find out person is diseased given that he is tested positive, which is equal to probability of E given diseased multiplied by probability of diseased divided by probability of E given diseased into probability of diseased plus probability of E given healthy into probability of being healthy. This is simple formula. Everything is available. 0.995 into 0.005 divided by 0.995 into 0.005 plus E given H 0.01 into 0.99. So practically 995 is getting cancelled and you get the answer 1 by. Very good. That completes our discussion on Bayes theorem. You solve whatever problems that you have in books. Every time it is going to be same. A wire of length L is cut into 3 segments. At random. Find the probability that these 3 segments form the sides of triangle. You have a rod of length L. So suppose if you make 3 pieces and call them X, Y, Z, and L is equal to 1. Then first equation that we get is X plus Y plus Z is equal to 1. Good. We know this is good equation for us. This is 1 of X upon 1, Y upon 1, Z upon 1 is equal to 1. Right? And we know what is the meaning of this equation in 3-dimensional geometry. What additional information we have? X plus Y should be greater than Z. X plus Y greater than or equal to Z. What does it mean? It means X plus Y plus Z is greater than or equal to 2Z. It means 1 upon 2 must be greater than or equal to Z. Similarly, 1 upon 2 must be greater than or equal to X and 1 upon 2 must be greater than or equal to Y. Therefore, if you happen to draw the diagram of what we are talking in 3D space, x-axis intercept is 1. This is x-axis intercept. Y-axis intercept is 1. Z-axis intercept is 1. So x-axis intercept 1, 0, 0. 0, 1, 0. Y-axis intercept 0, 0, 1. And hence we are talking about plane. Total points are the points in this plane of the triangle, because x plus y plus z must be 1. Okay, so this is what is the plane we are discussing. It is passing through 1, 1, 1 intercept of x, y, z axis. This is x, this is y, this is z. Now, what do we mean by z less than or equal to half? So z less than or equal to half, that means you take midpoint of this, and draw a line. These above points, this upper triangle is not available. Whatever you can have is below this line, because that line is parallel to xy with z coordinate equal to half. What is x is less than half? X is less than half means midpoint of this and midpoint of this. Join this. So you are allowed to go this side because origin is that side. Less than half. And y is less than or equal to half means you are allowed to go this side. So favorable is this. Total is total x, y, z. And these are midpoints of corresponding, I mean it's going to be equilateral triangle. Everything is equal. And therefore favorable upon total probability, required probability is equal to 1 upon 4. Now you can do a second kind of setup and solve the same problem. You have to use triangle inequality, where one way of going about it is, this is 1, have first cut at x, have second cut at y, and deal with those equations. You will get the answer. Okay, but then this is 3-dimensional geometry point of view is really good.